Now, let's have here number 36. So in the circuit shown in the diagram, each of the cells has an internal resistance of 1 ohm. So here we're going to have 1 ohm, and here we're going to have a 1 ohm. However, this cell is 9 volts, and then this one is 3 volts, and then we're going to have an R1 of 4 ohm, and R2 we're going to have a 2 ohm. And letter A, we have to determine the current in the circuit, and letter B, calculated the power in each cell, and letter C, comment on your answer to B. Now, if you try to look on here, number 36, we will apply the Kirchhoff's loop rule. Okay, wherein the sum of the voltages must be 0. So we're gonna apply the loop rule, wherein the sum of all the voltages in a closed circuit must be equal to 0. So here from the 9 volts, so we have here the positive, and so we're gonna have our Kirchhoff's loop rule on this process. And so let's try now to identify the voltages. First, we're gonna have a 9 volts here. So if you're looking on this part, we're gonna have a 9 volts. So we'll have 9 volts. And then, however, there is an internal resistance of 1 ohms. So it's like we're gonna treat it like a resistor. And so 9 volts minus IR, and the current is we don't know, and then we're gonna multiply it by 1 ohm. So here 1 ohm multiplied to the current. Next, from here we're gonna have a resistor, so that's still IR, that is current multiplied to 4 ohms. Next, if you try to look at the battery, this one is 3 volts. However, this is the positive side and this is the negative side, so we are flowing in the reverse direction of positive to negative. And that is why instead of putting plus 3 volts, instead of putting another plus 3 volts, you're gonna have it as minus 3 volts. Why? Simply because the battery that is from positive to negative, which is in reverse on this side, which is from here, we're gonna have here positive, and then this one is the negative side. So here minus 3 volts, and again there's another resistance of the battery here, wherein we're gonna have our 1 ohm, and so we're gonna simply subtract again, that is the IR multiplied to 1 ohm, and then another here we have a resistor which is a 2 ohm resistor, and that is minus I multiplied to 2 ohms, and the sum of the voltages of that equals to 0. So let me just arrange it, okay, without units. So here we could have 9 minus I minus 4I minus 3. I'll just remove the units volts so that our equation will be like clean when we solve our algebraic solutions. Minus 1 times I, that would be I, and then minus 2I equals to 0. And then we're gonna solve for I. So if we try to solve here, first we're gonna have 9 and 3. So 9 minus 3, that would be 6, minus, so negative 1I, this one minus 4I, this one will begin negative 5I, negative 6I, and negative 2i, so plus negative 2i, so this is negative 1, negative 5, negative 6, negative 8. And so this one will gonna be negative 8i equals to 0. And so solve for the I, that would be 8i multiplied to 6. And therefore I, that is 6 over 8. And so that is simply 6 over 8, that would be 0.75. 6 divided by 8, that would be 0.75 amperes. Therefore, the current in the circuit that will gonna flow here, that one would be equal to 0.75 amperes. Now, how about calculate the power dissipated in each cell? How about the power dissipated in each battery? Now, for the power in each battery, so the power at 9 volts, that would be the current multiplied to the voltage. Therefore, the power at 9 volts, that would be 0.75 amperes multiplied to the voltage, which is 9 volts, and that is just 3/4 of 9, and that would be equal to 9 times 0.75, that is around 6.9 times 0.75, that is 6.75 ampere volt, that is watts. Okay, next, how about the power on the power on the 3 volts battery, that is IV, and that is current, which is still 0.75, and the voltage here is actually negative 3 volts, right? So 0.75 times 3, that would be 2.25 watts. So that is 3 times 0.75. So that is negative 2.25 watts. However, if you try to look at the power, that's a scalar quantity, right? So this one calculate the power dissipated in the cell. So this one is our answer. That is for 9 volts. That is 6.75 watts. But power for the 3 volts, that would be 2.25 watts. And what does negative mean? So comment your answer on your answer to B. So the power in the lower cell, or the power in 3 volt battery cell is negative, and that implies that is being charged, implying that it is being charged. Okay, and so that would be our answer for letter C.